Would you mark points off if they're tested or twist isn't like?
Enunciated.
That's a good question. Use your best judgment. There's some of those, more of those best judgment questions. Sophia, what do you think? Would I?
Wait, what was the question?
I don't even know.
You're gonna be picky about if it looks like it's a straight line or if it looks like it's doing the cube thing.
Okay.
Because that's the most reasonable thing.
Okay. Maybe I'm not committing one way or the other. It seemed very insightful to me.
I failed to be able to.
Oh, this would be for you.
I like because it has to go on this. I would be able to. Yeah, that's right.
I'm gonna be calling 3 people up.
Like. That's the end behavior is down. Yeah, but what's in the middle, it bounces off the 4 and does the curve through the 2 and then straight through the 3. So I did this.
For number 1, whenever you're ready for number 1, Lucy, if you can show us that one, please. Walker, number 2. And for number 3, Birdie. Whenever you're ready. Whenever you're ready. So 1 over here, 2, 3, and we'll do 4 together. You should definitely work on 4 if you finish 1, 2, and 3.
Oh, bounce off the 4 through the 3, straight through the.
Let's see.
Oh my god, I have to swap it.
For number 1.
Wait, for number 3. It goes on whatever you do and down.
Yeah, over here.
Oh.
I can do it.
I did all of them. Or no, okay. Let's do it.
We're doing 4 together.
Well, you.
We are gonna do 4. No, do 4 on your own, and then I'm not gonna call someone for that.
Look at one. That is not what I. Wait.
Wait, is it?
Oh. Yeah, it is. Oh, yeah. Yours is so flat. Okay. It's the same thing. Yeah, touches the two guys. Yeah, same thing before. That's pretty good. A compliment of but it doesn't the squiggly thing.
If you have it, the only one compliment, you should be rich.
I'm gonna factor it with the triangles. Oh, yeah, it needs to go down.
One is.
Is this feeling accurate?
Three?
Yeah.
No. I couldn't. No.
Wait, I'm like really. I'm not gonna. Wait, this one has to be a parabola.
Because what I got for the y-intercept is like really low.
Bounces off.
We don't care.
Yeah.
Oh.
Parabola.
What do you get?
Like negative 1,000.
Parabola?
You mark it.
Twists.
Wait, yeah, no, it goes up and then down. We have to be doing
Oh,
something.
yeah.
No, just up and then down.
It hits 3 and then goes down.
Yeah, oh, it was upside down, yeah, no, one
No,
fifty.
you had it.
Go down,
No.
no. Yeah,
Yeah,
and
no.
then bounce,
Bounce
bounce,
off.
bounce, yeah. That's good. Wait, let me do number 4. My schedule.
Okay, are we okay with 1, 2, and 3?
Yeah.
How do you find y-intercepts of a function?
Maybe exercise.
Make x equal to 0. So Lucy was nice enough to go through that work, and she got a y-intercept for number 1 of negative 1,152.
52.
Does that mean we have to go really low down? No, I don't care about the scale of the y-axis. So if I ask you to mark the y-intercept, calculate it, and just wherever your graph landed, that's your scale. Unless you mark that negative 1,159, so whatever that number is, that's what you just mark it. So don't feel the need to do anything else to that. You don't have to like just tell me where 1 is or negative 1,000. The behavior at the 3, what are these 3 things called? They're called the 3 zeros. Is the behavior okay at all of them? Let's see. So at the one that's multiplicity 2, it touches it. I would want to see a little bit more attention to detail for this quiz or test. It looks like we have it looks like maybe I'm gonna put the negative 4 right over here. And for those of you at home who are listening at home, you can't see what's going on here. I apologize for that, but I have drawn it for you. Okay, so that and then 2 just goes right through. Oh, it looks like it goes through. It needs to go through with
the curve, like the thing.
yeah, with the thing, with what would I call it?
With the
Like the x cubed. It's got to look like a cubic function. I called it a twist or a flattening out. And the way you do that is you approach it like you're making a parabola, like you're just going to touch it. And then you do the parabola on the other side. You do the swoop up like that. That's a twist I want to see. Or flattened. But yeah, very nice. The behavior was perfect. Exactly what I was looking for. Just pay attention to the cubics. Are we okay with this number 2? Let's see.
wait, actually,
Multiplicity of 1, does it look like that? Yep, going right through. Yep, nothing crazy. At 2, does it look like multiplicity 2?
yeah.
Yeah, that's what it should be. Does this look like multiplicity 3?
Yeah.
It does look like they made an effort, but if I were to zoom in just at that place on the x-axis, doesn't it go right through? I'm just gonna fix it up. Just we're just preparing for the real event. Could you make sure that yours looks exactly like what or really close to what I'm hoping for?
Yes.
And check with your neighbor, of course, after you've done that. And if you and your neighbor are not sure, you have people in front of you, behind you.
That was hard.
Okay, so does it look like this
Yes.
and then this?
Yes.
One tip, if you go up too far, it becomes difficult to make that swoop down. Maybe some of you are dealing with that. You do extremes. You don't need to be too high, too low. In fact, I don't care about how high or low it goes. I just care above or below. Yes.
Like when we draw it, can you like look at mine? It's like I go down and then I just go back up.
I'm talking about this one here, though.
Yeah.
So it's got to go through it. So going down and coming back up would be incorrect. But if it's good for 2, going down and coming up. Yeah, swooping down and then coming below it like this. How do we even know that the end behavior is down on both ends?
Because it's a negative.
The coefficient is negative and the degree is 6, so we know it's gonna go down and down. So it's like a negative parabola, down facing parabola. So I see something going on here. Is this a twist?
No. It's not.
Should it be a twist?
It is a
That looks,
twist.
that is a twist. Okay, so it's almost there.
Yes.
It's almost there. You see what I'm gonna change?
It's twist.
What's the?
Yeah, this, I see what's going on here. This is what I need to change. Something like that. This is a little flat. 2 looks like it's multiplicity of 1, 3 looks like it's a multiplicity of 2. I'm gonna put a tick mark there or a dot there to indicate exactly where that's. Any questions? Walker?
Is messing up like the drawing of the twist, that's like half a point.
Because it's.
I don't take that. I don't take that points. It would be a full point up. But if there are multiple graphs, I wouldn't take up that twist issue multiple times. One thing you need to be careful of, and this is something I would take off for, is this. Something like that. Twist is just going along. It's not flattened down. So be careful. If yours looks like it's just crashing into the x-intercept, then you've done something right. It needs to be a gentle landing and then gentle going down. So not like this. It should be a gentle slope into it, like that. And then gently go down into the abyss. So what do you think? Should I take the point out for the cubic issue?
No.
After all this, of course. I needed to be rewarded by getting a point when you get it. Okay, let's talk about number 4, shall we? It's a little different from the others, isn't it? So I draw those in for people at home. For 4, I want some help. I want a direction here, specifically from the one and only Charlotte. Oh, good question. Can we factor this? It'd be nice if you could factor, because then you'd have the zeros and you could do it like the other ones. Yeah, this one doesn't factor though. It's a good first thought, and I appreciate that. Do you have any second thoughts? I'm having second thoughts about coming to class today now. I'm just kidding. Okay, I want some other ideas. Thank you, Charlotte. Jaden, do you have any other ideas? Besides, it doesn't factor, so where can we go from here? Oh, good question. How would that help?
Well, because you can factor out the 2,
Okay.
and then you can get x squared minus 6x, and then you can leave it blank.
What's your goal?
To get to vertex.
So maybe we could put it in vertex form. I really like this idea. Thank you. So yeah, it's you said factor out the -2?
Yeah,
Out of how many terms?
the -2 and 12.
Yeah, exactly. Just the first 2 terms. So we have plus 6x here. Leave the space like you said. Did anyone already do this? Go through this process? Okay. I'll give you a chance to finish. They laugh.
Yes.
They laugh.
It's not because he was wrong.
Because he was completely great.
Yeah.
It's good taste.
Yeah.
The man has fine taste. Completing the square should be a joy. Make sure your neighbor's doing okay.
Um,
The 2 is.
Where'd you get it? Oh, it's -18, you're right. What, it's 20, 8, 29, 30, 31.
Did you get it?
Vertex form.
Into vertex form. So we could graph it. Charlotte, are you now thinking, of course? Yeah. No. Right, we're going down one road. I mean, you switched to a completely other road. So mean. Jerking you all over the place. Okay, let's go through this together. Bless you, by the way. I remember our goal is to have the exact same thing every line. Like these, the first and the second line are exactly the same, aren't they? Just kind of change the form. The number I'm gonna add is a 9, and we got that from just taking half of 6 and squaring that. So are these two lines the same? No, what I've done by adding 9 here is actually, I'm actually subtracting 18 from the right side. So to counter that, we have to add 18. Check with your neighbors. Yeah, where is that? Where's this all coming from?
So what do you mean,
So then like, it's
Why are you adding
zero, so negative two.
oh,
You said to add the 18 back. So
What?
You said subtract.
fun, I don't get it.
Hey, so remember, our goal is for every line to be the same. Right now, you see that this 18, this plus 18,
Why is it Boston?
this plus 18 is undone by the minus 18? Is there a negative 18 up there? So when we added 9, it's not actually adding 9. We actually subtracted 18 when we did that. We had to undo it by adding 18. It's just kind of hidden. Okay. From here, Jaden, do you want to continue? Just what do I do with this?
Yeah, you could. It's a perfect square triangle.
Oh, nicely said. Plus 3 squared. Is this helpful?
Yes.
Quite helpful. So now when we graph it, I want to do this as quickly and efficiently as possible. So the points I'm going to draw first, well, the point I'm going to draw first is the vertex, which is negative 3, 5. Thank you for remembering. It's the opposite of what you see there. What's the next easiest point? The y-intercept. The y-intercept we know is,
5.
should I plug in my 0 right here?
Yeah.
You can plug it in here, third line, second line, or first line. I suggest the quickest one, specifically the first line. When you plug in x equals 0, we get 13. So this is down here, or negative 13 right there. Could you just check with your neighbor? What's it? The quickest point to the next quickest point to get? What is it?
Yeah.
Right. Do you know it? Do you know the next point that I'm looking for? I'm looking for easy things next. Nice. I remember through that vertex is a vertical line called the axis of symmetry, which means whatever's on the left is duplicated on the right and vice versa. So that negative 13, we're going to take that over to the other side where the coordinate is the x coordinate negative 6. Is that clear? And this is enough to draw a decent parabola. That would be sufficient. Oh, because we have a parabola that is same on the left and right. So 3 to the right of that axis of symmetry is negative 13. 3 to the left of negative 3 is also found at negative 13. Is that clear? And thank you for asking, by the way. I could get 2 more points pretty easily because that negative the leading coefficient is negative 2. Do you know which 2 I'm talking about? Well, I'm not going to go up 1 and over 1. I'm going to go down 2 and over 1 in both directions. So like here at 3, it'll be like here and here. And that's all I'm going to do. If I wanted to find the x-intercepts, could you? What tool would you use to use the x-intercepts? Find the x-intercepts. Set equal to 0. It doesn't factor, so you're going to quadratic formula. Either quadratic formula here or set this equal to 0. So move that negative 5, divide by negative 2, and then take the square root. It's just much easier once it's in that vertex form. But I'm not even going to ask for that right now. Just draw this. Very poorly done. If I were taking a quiz, I'd want to erase this. I don't like that this went like it's swooping out a little bit. I'd want to erase it and make sure it's A well-behaved parabola. Not one of those out of control parabola. Are we good? Are you feeling like this warm-up? You're in control of the material from the warm-up? Hope so. Okay, today what we're gonna do after the first part of the lesson, I'm gonna bring back possibly your least favorite part of elementary school math. Long division. It was your favorite? Interesting. That's very interesting. Okay, we all did this already. Look at that. Like it's literally long division. So I want to see if you can remember how to do this. Take a moment.
Should we show our?
Yeah, show your work.
We didn't propose.
Any necessary work.
First one.
One or two people are like, I'm not sure actually very well.
Yeah, I don't think I learned it right. Like, I feel like that was just not very hard.
Was that pretty?
I feel like I got through like fourth grade math and I was like, I never used it, but I got.
Little did you know
It would come
that
out.
January 28th would be here, 2026. Want to check to see how your neighbor's doing, making sure everything's good? Oh, no decimals. I want you to take it back to early long division. I want to see a little r. Little r. Remainder. Isn't that a fun word?
Okay, I'm done. You got it.
It's what remains, so it's the remainder.
It's so pretty, like the arrows are just so. That's okay.
My first one got spot.
8 seconds.
Yes. Yes, I mean, we're so smart. I know.
Okay, ready or not? I'm gonna go over this. Were the first words that go through your mind for this? How many times does 26 go into 39? Are those the exact words that went through anyone's mind? How many times does 26 go into 39? Okay, perfect. And the answer is, of course, 1 time. So then we take that 1 and multiply by 26, and then we subtract to get that 13. And now, what are the next words that go through your mind? Bring down the 8. Yes, so this is now an 8. Now the question you ask yourself is, how many times does 26 go into 138? And we're going to estimate that by figuring out how many times 25 goes into 138. Did anyone do it like that? So I'm just, or maybe you could have your natural intuition, but I know 25 goes into 138 5 times. So I'm going to guess because that's really close to us. And if it's too much, then I'll adjust. But 26 times 5 is something like 130. Oh, good. If that would have been more, then we'd have to bring that number down, of course. We take this number and subtract, getting 8, and now we bring it down. Yeah. And now we think, how many times is 26 going to 83? And the answer is 3. And so this is now 28 and 5. The 5. Now, we could continue on with decimals if we put 0.00, but we're doing that 5 as the remainder. So we have 153 remainder 5. And as you went into fractions, you probably recognize that this is 153 and 5. 26. Right? Does that seem familiar? Like what you did the remainder, you made the mixed fractions. Okay, let's talk a little bit about vocabulary. This number on the top is called the number that a word that you all know. It is a quotient, yes. Would you check to see if your neighbor remembers the other not variable, the other vocabulary? Oh.
Yeah, I think dividends divided by goes outside of the house. Yeah.
So 26 is called the,
Dividend.
No, the divisor.
is it the divisor or the dividend? It's a divisor, yeah. And the other one is called the dividend. And I'm not going to be testing you on those, but you'll be coming across those words from time to time. So that's just a little trip down memory lane. Do you like that one? Man, you didn't like that very much? No? I'm sorry. Yeah, not so pleasant, but it's important because today we are finally dividing polynomials. And the way we do that is using long division, right? We've done addition, subtraction, and multiplication of polynomials today. JD, the way for this moment, we are dividing polynomials. Yeah.
Reconvene square.
I don't think that's going to be part of it, but thank you for your enthusiasm. Okay, so the way this works is exactly the same. So x squared plus 10x plus 21 is on the outside. On the inside, on the outside is x plus 3. And after you set this up, go ahead and put your pencils down. After you write this, just put your pencils down. Okay, so pencils should be down now. Okay, listen up. So the process is almost the same, except I'm not gonna try to figure out how many times x plus 3 goes into x squared plus 10x. It's too strange. It's too abstract. So all I'm gonna do is I'm gonna figure out how many times x goes into x squared. In other words, x times what equals x squared, and that answer is x. And just like I did before, I'm gonna keep pencils down. I'll give you a chance. Don't worry, crazy people. And take that x and multiply it by this entire thing. Put pencils down. That's an honor code violation at this point. Just kidding. So we have this. Next step. Don't say anything. Next step, of course, just like long division, we subtract. Yeah. And when you subtract, just make sure I'm putting parentheses on the subtract whole thing. And that leaves us with 7x. The next step is to bring down, bring down that 21. Now the question we ask ourselves is how many times does x go into 7x, or x times what equals 7x? And the answer is 7. And that's why up top I'm going to put not a 7, but a plus 7. We're doing polynomials. This is the 7x plus 21. And when I subtract, we're left with 0, which means that x plus 3 was a factor, right? If there's no remainder, that means this thing divided evenly. And if we look into it, I think we could have known that in the beginning, couldn't we?
Yeah.
How could we have known that in the beginning? Yeah, Avery.
So you could have split into x plus 3, x plus 7, and then just divided by.
Hey. Very nice. It's not really a perfect square trinomial, but it's a factorable trinomial. And then, right, you can divide this by x plus 3 and get back plus 7, but yeah, so x plus 3 was a factor. I'll give you a moment to copy it down. Yes, Sophie? Oh yeah, because I'm multiplying by this whole thing here. X times x plus 3. Just like with regular long division. That was a good question.
What was the first step? You did x.
How many times does x go into x squared? Just very simple, x into x squared. I'm not trying to figure out how many times x plus 3 goes into x squared, or x times what equals x squared. The answer is x.
And then how did you get to subtracting x?
I multiplied that entire thing. And then any other questions? Avery, you got it? What's that? Oh, for this.
How does that work? That we're just allowed to just look at one part of it.
Right? Because we have x's. Avery, do you have a question?
No.
Okay. When it's arithmetic, it's very specific about how many times a number goes into another number.
Yes.
But with x's having a variable in there, it's weird, like asking how many times x plus 3 goes into here, this whole thing. And it gets more and more abstract as we have subtraction and other exponents. So all we care about is x going into x squared, and that's enough for this purpose. So I hope you'll be okay with that as we practice this new skill.
If it was negative x plus.
Ah, that's a good question. We'll talk about different variations of this. And I love that you're extending the idea. Thank you. Perhaps your other question was, can we try another one? If so, the answer is yes. Look at that. First, set it up. Let's put something inside the box and outside the box. Make sure that your neighbor did it correctly because this is not so well behaved already. Outside is 3x minus 2. The inside begins with, thank you, 6x cubed. My standard form. Let's see if you could already do this. And if you want to do it with your partner, you can. Or if you want to wait for me to go over it, you can. The number up top is 2x squared. Does that make sense? Do you have that already? Because how many times? 3x times what equals 6x cubed? 3x times what equals 6x?
Three x times what equals 6x cubed, and the what is 2x squared.
There it is.
Cubed minus 4x squared. Oh, here it is. And like minus 5x, and you bring down minus 5x. How many times does how many times 3x? X squared, no, what?
I was just 3x when we make some.
Two, one x. I'm still on. 1x squared times
I'm gonna go over this in about 15 seconds. So if you're thoroughly confused and just want to wait.
minus x squared. Look, because that would mean that. Oh no, minus x. That would mean that that's negative 3 x.
Wait, I got this in.
Where?
In 5 seconds. 4, 3,
No.
2, 1. Okay. So I know that some of you are still working on it. I'm going to ask you to follow along as I go and just make sure that you're thinking as I'm thinking with this. Do I need to talk about that 2x squared? That just came from looking at this times what equals this. After we have that, just like regular long division, I'm going to take that 2x squared and multiply it by
Yeah.
the entire outside. So that's why we're going to have now 6x cubed minus 4x squared. Who already has that on their paper? Very nice. If you don't have it, then figure it out as we continue. We take this and subtract. And by design, this will have to cancel out. If it doesn't, then you've done something wrong. And what am I left with when I subtract? 3x squared minus 5x. And then we bring down that 5x, and minus 5x specifically. And now what question goes through your head? That may be too much. All I care about is how many times 3x goes into 3x squared. Right now I'm doing this and this. That's all I'm looking at. So how many times does that go into 3x squared? It's x. And another way to ask yourself, 3x times what equals 3x squared? And the answer is, of course, x. So take that x and multiply, yes, by the entire outside. So 3x squared plus 2x. Oh, sorry, minus 2x, isn't it? Do you already have that? Minus 2x? And now we subtract, leaving us with negative 3x plus 4, because we have to bring down that 4. And now we're looking at this and this. What's the answer that goes through my head? Minus 1. Because 3x times negative 1 is negative 3x. We take that, multiply it out, negative 3x plus 2. Is that right? Plus 2? I take this and subtract, and that's how we get 2, is that right? Did anyone get that far? Do I have to bring down something else? No, we're done. That 2 is called the remainder, and it tells us that 3x minus 2 is not a factor. Is that clear? It's definitely not a factor because there is a remainder. Isn't that how division works? Yes.
Should we answer it just like?
Good question. I should read the question because I didn't actually answer the first one. So let's do this one. It says state the quotient q of x. What is the quotient for b? Yeah, for b, the quotient is 2x squared plus x minus 1. That top is a quotient. Q of x. And the other one, r of x, is equal to 2. Yay. Come on in. Welcome, Jihan, to the club. Welcome. I'm glad you made it. So for A, Q of x is equal to x plus 7, and R of x is equal to 0. And there was no remainder. Yeah. Yeah, it's weird, even though there's no x in there. Who knows what comes? Who knows? But what kind of function is this? That R of x. Do you know what kind of function it's called? Well, let's go to Q of x. What kind of function is that? What is it? It's quadratic, isn't it? It's x squared. So yeah, R of x, is that linear? If it were 2x, it would be linear, but it's just 2.
Oh, polynomial.
It is a type of polynomial, but I want more specific. It's a type of monomial. Oh, you guys are tricky. If there's no, I heard it. Who said that? Yeah, nice. Is it constant? There's no variable, so it's constant. No matter what you plug in, it'll always be 2. It's still a function of x. There's just no x involved.
So 0 is the constant of n? Wait.
I'm just saying it's a constant function.
Oh.
There's no variable.
Oh.
This one is a quadratic function. This is it's a quotient. But let's move on, shall we? Perhaps your question is there an easier way to do this? Was that on anyone's mind?
Yeah.
Okay. The answer is maybe, but first I'd like you to do this problem.
Together?
I'll just on your own and then compare, and we'll do it all at the same time.
Okay.
I'm gonna do it silently up here. I'm gonna freeze it so you can't see until I release it. Check it with your neighbor when you are done or stuck. Did you get it? Can you show me the remainder? Can you show me the remainder? Interesting. I'm seeing different things.
Oh my god, this is what do you mean?
Yeah, something different. Oh, did I do this wrong? Oh, I see. I did it wrong. Thank you. Okay. Here we go.
Look, I'm agreeing with Walker.
Yes, we got the right answer.
Yeah, that.
For some reason, I put 55, so you guys corrected me. 53. Does this match yours? Okay, folks, for this next step, we're going to talk about something called synthetic division. For this, what I'd like you to do is put your pencils and or pens down and sit back, relax, and observe. And implied, of course, is enjoy the show. Okay, first thing I'm going to do is I'm going to recreate the same problem, right? Check. I'm going to do the same problem, but I'm not going to use this whole long division stuff. You ready for this? Okay, here we go. The first numbers I'm going to write are 1, 4, -5, and 5. Do you all see where those numbers came from? Take a look, and I'm sure you can find where they came from. You remember what the original problem is? You see it? Okay, now I'm gonna draw what's called a little box thing. And in this little box, I'm gonna have a 3. Do you see where that 3 may have come from? Okay, now from here, what I'm gonna do is I'm going to bring, and don't write anything yet. Bring down, and then multiply, and multiply, dot. So watch it. So first bring it down. I brought down the 1. Now I'm gonna multiply. 3 times 1 is 3. And next I add, multiply. Do you see where that 21 came from? 3 times 7 is 21. Add, I get 16. 3 times 16 is 48. And 5 plus 48 is 53. Do you see the answer here? Do you see the answer from the original problem that we did? Yeah. So yeah, this right here, the 1, 7, 16, here we have it. So now I can write my q of x from here. That's a g. I'll give you a moment to now copy this down.
Someone probably doesn't figure out that it was works, and then that'll just be. Nice. No, it's. I know, it works.
Yes, Lucy. Oh, yes, there are. Yes, good point. Can only be used when dividing. I can write the word dividing by x minus a.
So if there was like 2x minus 5.
Yeah, 2x minus 5 wouldn't work. The x plus a would be fine, but it's got to be leading. Yeah, the x can't have 5 coefficients. That's what it is. Okay. Now, before we move on, I just want to show you that all this is doing is cutting the fat of this. Like here we subtracted, but why are we adding here? The -3 kind of switch to +3 to set us up to go into addition. Do you see this 7 over there?
Yeah.
And the 16? Is there a 21 over there? Yeah. Yeah, so it takes all of this and just kind of condenses the essential parts, removing all of the middlemen. So it's the same process, we just get to the answer much quicker. Okay, so would you please set it up, but don't go through the problem? I want to see the little box. I want to see the numbers. Check with your neighbor. There is one trick embedded in this one. Let's see if you can figure out what the trick is. So don't actually start the process until we are all correctly set up. So of course, inside the little box is a -2. Outside the box is, we start with a 5 then. 5, 0. Does that make sense? We need a 0 there. That's the trick. And then of course, 6 and 8. I'm going to give you a chance to see if you could actually do this one. Did you get it? Did you check with your neighbor? Check with the people in front of you, behind you?
Because you multiply 26 by -20. So yeah, but like, which is, can we break it down?
Well, yeah,
Break it down. Five x.
five x squared.
Five. Yeah.
And it's negative 40.
Where did the
Okay. Well, who'd like to just talk me through this? Like, what do I do? And I want them to know the numbers. Anyone feel confident enough to walk through? Yeah, Jake?
So you put the 5 down.
Okay.
-2, so it's -10.
You could just give me the numbers.
6, -52.
-52. Okay. They want to have these same things? Yeah, perfect. Thank you. Very nice. So we know that when we divide this polynomial by x plus 2, well, we're dividing a cubic by a linear, so I hope it makes sense that the first term is going to be what kind of term? It's going to be quadratic, right? So that's why it's 5x squared minus 10x plus 26. That is our answer. Oh, that's q of t. Actually, q of t. Q of x, and then r of x is -44. Yeah. Weird, huh? We've gone into such abstract territory. Have negative remainder. And what this means is if you were to take this and multiply it by, whoa, come back. No. Oh my goodness. This is so bad. Why? I don't want to give you feedback. Okay. We're going to take this and multiply it by x plus 2. If you take this multiply x plus 2, you have to add -44 to get back to this. That's how these pieces fit together, but that's not important right now. It's what's important is how to get that quotient and the remainder.
5.
Yes.
I wanna know.
Oh, I don't know. That's a good question where it came from.
Spent my life like trying to find tricks and found this trick and was like, wow, it works for everything.
Well, and part of algebra is we want to be complete. We've added, subtracted, multiplied, but so we need a way to divide, and this works. Algebra 2 teacher, high school. Would you please try B? Make sure that your neighbor set it up well.
Did you remember the zero?
This would be a one.
Don't mess with me.
It's a 3. Wow, there is a 0.
Yeah, okay. I got you. Did you remember the zero? No. Not. So it goes from 4 to the 4 to 3 as squared, so you have another 0 to account for the u.
Good catch.
Thank you.
Yeah, there's a missing one.
Update.
Okay, that'd be right there.
I can see it.
When it's the third one, it's hard to see. It's the second one, it's not too bad. I will be calling on one lucky individual to help me through. Are we ready? Does it get ugly? Does it get ugly?
Oh, you had. Oh, you're right. You're right. Wait, what's?
10 seconds. On someone.
It's 5.
Are you asking me?
Six.
Okay, ready or not? Here we go. Avery, can you help me out? What goes in the little box? 3. Okay, what goes outside the box? Okay. And then just tell me the numbers and I'll put them in the right place.
7, 21, 21, 63, 60, 20, 22, 5, 6.
Do we agree?
Yes.
Nice. Can you tell us what Q of X is?
X to the 4 plus 11 x eight plus 21 x squared plus 60x plus 182.
And R of X. 549. Are we good? What do you think about this synthetic division stuff so far? This is- don't you agree? Way easier than long division? Way easier.
Yes.
So if I can we're multiplying for when it comes like between the negative 3 and the 2 like that, we multiply with 60 by the 3.
3 times 60.
Nice.
180.
Then 182. Yeah.
There you go. It's all working out. Yeah. Good process. Yeah, good. Any other questions? Okay. If there's time at some point, I'm going to show you why this works, especially the next thing. Next thing is called the remainder theorem. Do you know what a remainder is? I hope so. We just talked about it extensively. I'm going to motivate this by just jumping into example. That says to use the remainder theorem to find f of 2. We're not going to use the remainder theorem. I want you to find f of 2 directly, which means we're going to take that 2 and plug it in. But go ahead and do that at the moment. What'd you get? 5. Okay, so 4 times 4 plus 10 plus 3 equals 5. Do we all agree that it's 5? Okay, I'm going to put a line here. And on the other side of this line, I'm going to put a little box. Inside this little box is going to be a 2. Outside the box is going to be 1, -4, 5, and 3. And I'll let you do that as I work through this silently. Maybe we can have a little race. It's not fair for me to say little race while I'm ready to go. I want you to notice the remainder. So this is the remainder theorem, but this remainder is the same as if we were to just plug in that number. And you can imagine that if I ask you to find f of 7, you have a choice of either plugging in 7 directly or just putting a 7 in this little box and figuring out what that remainder is. It will always be the same. And that is the remainder theorem. So I'm going to put that into words so you can put it in your notes. when a polynomial function or polynomial, not function, is divided. Someone's so happy they're singing. X minus a. I don't blame them. This is happy stuff. I see if you could there's definitely someone in another class. Okay, when a polynomial function is divided by x minus a. Yeah, it is. The jokes about corners and everything. Yeah. I love that joke. I love it. Please discuss with your neighbor. What's the rest of this sentence?
The remainder is equal to.
The remainder is equal to a? Is equal to f of a. Isn't that what just happened? Isn't that what I did here? Like there's 2 here, it's coming from like an x minus 2. X minus 2. And it's the same as f of 2. The remainder is the same as f of 2. Oh, so I'll give you a minute to finish that. F of a, right? It's this, right? It's just a. Like this, if I were to put that in parentheses, remember that dividing by, oops,
Oh, yeah.
x minus 2, right? Yeah, that minus thing gets complicated, a little bit confusing, but you'll get it straight, I'm sure. Can we move on? The factor theorem. We've already spoken about this. Yeah, let's see. We spoke about this here. When the remainder is 0, this x plus 3 is a factor. Does that make sense? Okay, so I'll put that into words for you. I'll help to like official mathanese. When a polynomial function, I'll just say polynomial, is divided by x minus a and the remainder. I'll let you finish this based on what you already know. The remainder, and discuss with the neighbor what's the rest.
Then x minus a is a factor of that polynomial.
Yeah, and the remainder is 0. This is oh yeah, so then, what was the rest? Then what? Is a factor of the polynomial. That's nice and complete. I hope that makes sense on just an intuitive level and your understanding of division. Okay, so here we're trying to solve an equation. Does this factor? Not that we know directly, like we can't factor by grouping. That'd be crazy, but it does tell us that 3 is a 0, which means I should be able to factor this into x minus 3 times something equals 0. Yes? Right? The fact that 3 is a 0, just like that warm-up, means that this is one of the factors of the polynomial. How do you figure out the rest?
It says that.
Discuss with your neighbor. How are you going to figure out the rest of this?
Wait,
Synthetic.
Synthetic division, obvious.
Just gonna synthesize it.
Synthesize it. Yes. So what are you going to do? What divided by what?
Ball.
The three in the box and yeah. Right, aren't you trying to figure out this polynomial divided by x minus 3 now? To get the rest? Go for it. I'll do it silently. We can, want to race?
Are we doing it first? We're basically.
The first equation. Okay. I'm on mark. It says go.
No. Don't tell me, don't tell me, don't tell me.
I've literally been doing this for 75 years, so I probably beat you. Is that zero a surprise? Why not? It's a zero. It's factorable. So we knew that it's going to be a zero. So what goes in the big parentheses here? Plus 3x minus 2. So if I want to find the other solutions to the equation, what do I have to do? Factor it. Now that we have a quadratic, is that factorable?
Wait.
It is. If it weren't factorable, you could always use quadratic formula. Did I do that right? This is a minus here. So when it says to solve it, we now know that the solutions are x equals 3, -2, and 1/2. There we go. Any questions? Do you know that you can't spell function without fun? That makes perfect sense, doesn't it? Also without funk. Oh, look, there's one for you to try. Oh, what a joy. Solve that equation. Check with the neighbor when you're done or stuck.
I think we'll just expand this and be done. Like, I don't know how, I just gotta guess. Well, it's -6 and 5, but I don't know what the other one is, so I just. Like how you.
Oh, that's fine.
Forget it, but that makes sense.
Oh.
That's more right.
Okay, so I'm gonna ask for your attention now. We'll go over it together, but I hope that for big idea purposes, that it makes sense that I'm trying to factor this. I know that the first factor is x plus 1. Is that clear? X plus 1. And for the other factor, I don't know what it is. That's why I'm going to use long division. Synthetic division. We're dividing by x plus 1. So it qualifies. In the little box, I have a -1. Out of the box, I have 15. Any tricks here? No, it's well behaved. Okay, so 15, -15, -1, 1. I have 2, 2. Is it a coincidence that there's a 0 there? It told us it's a zero, the remainder is zero. But now I do know that this is a 15x squared minus x minus 2. Does that factor?
Yeah.
Do you know the quick check in your head to know that factors? It's this. What number goes on top? -30, and the bottom is. Does this have an answer? Yeah, it has an answer. So I'm just going to do a quick check in my mind to see if it works. Since it works, I'm not going to be wasting my time to factor. Oh, maybe I will. I think we need this, but I want the answer from one of you because I don't want to take the time right now. Yeah, Jaden, 3x plus 1. Do we agree? Yeah, so for this, you have to be able to factor, and if you want to use this, you can, but you have to be able to do it.
How would you factor by one?
If you can, well,
Minus 6x plus 5, 15x.
yeah, 15. Exactly. Yeah. Yeah, for the diamond method, you have to split up this middle term here and then factor by grouping. Okay, so we have x is equal to, as we knew, -1, but now we also know it's 2/5. I can do an order here. 2/5 and -1/3. Should we check those other two? You want to just plug it in? No, we have better things to do with our lives, and it worked out so pretty that it's got to work. Any questions? Would you take a moment? Today was a huge day. What do you think about synthetic division on a scale of thumbs up to thumbs down? What do you think about it? I hope you liked it because we're going to be using it a lot. And it's in this unit and sometimes in the other ones, but this unit's going to be used a lot. Will you please take a moment to discuss with your neighbor some of the most important things from today?
All of us. Yeah. Yep. I learned the. I learned the remainder, like, I also learned the remainder zero.
Okay, what's important? Don't pack up yet, guys. Sophia, what's one thing that you need to bring with you from today?
Zero, then that is a factor of the polynomial.
So you found a factor, right? Yeah. Okay. Good. Mia, what's another important thing? And what does the remainder theorem tell us? The remainder is equal to. Are we good with that? No. What's another thing that we have to remember for today? Yes. You think that's a big thing? Yeah. Remember synthetic division. Also remember long division. And you're going to have to use long division if you're not dealing with x minus a. So if you're like dividing by 3x plus 5 or x squared minus x plus 7, which might happen, you have to use long division. Anything else? When you're using synthetic division, just make sure that you're representing all the coefficients, even if you have to include 0. I guess that's all the big stuff. I'm going to close up the meeting, but I have to give you your quiz back. So if you'll take a moment, give me a moment.
I'm gonna drop.
Oh, no.
Oh.